Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 18 on the 2005 Cayley contest. Harry the hamster is put in a maze, and he starts at point S. The paths are such that Harry can move forward only in the direction of the arrows, and we do have some arrows going on here. At any junction, he is equally likely to choose any of the forward paths. What is the probability that Harry ends up at B? Okay. So we're dealing with probability. So we're going to work out some probabilities. And at any junction, he's equally likely to choose any of the forward paths. So equally likely means that if there were, 5 options, then it would be 1 out of 5 that he takes this option, 1 out of 5 he takes this option, and so on. If there were 3 paths, it'd be 1 out of 3 he goes here, here, or here. They're all equally likely. It's all the same number in terms of probability. Okay? So that's equally likely, and that's going to help us. So we're going to draw this picture here in our notepad. Okay, so it started at S, and then it branches off into 3 groups. Then branched off again down here. And what did the rest of the picture look like? So those ones connect up, and then it's got sort of another branching here. These ones went down. I think that's what it looked like. Yeah. Okay, so he basically can only move downwards, is the point. But we have But 4 areas to keep track of. This area right here, he makes a choice. Here he makes a choice, assuming he went down this path. Here he doesn't make a choice, but we'll get to this point in a moment. And here he makes a choice. Okay. And we had A, B, C, and D. Now we're only interested in the probability that he reaches B, correct? Probability Harry ends up at B. Okay. So first thing I'm going to do is I'm going to label the probabilities that he takes each given path. So up here he has 1/3 of a chance of going down this way, 1/3 of going down the middle pipe, or 1/3 to go off to the right here. Okay? These are his options at the very first choice. Now, assuming he's taken one of those, what are his options later on? 1/3, 1/3, 1/3, because there's 3 paths, and each of them is equally likely, as we're told. And down here, just above A, we have 2 paths, equally likely, so it's 1 out of 2 for each of them. Okay. So, now we need to talk a little bit about how probability works. If he travels down path X and then path Y, and X has a probability of, say, P little x, and path Y has probability P little y, then the probability that he does path X and then path Y, we multiply. And in probability means multiply. Okay. What's the chance it's going to rain today? 10%. What's the chance that I'll trip and fall on the ground? 1 out of 100. So what's the probability that it rains and I trip and fall on the ground? We multiply them. Okay. We multiply along paths in what's called a probability tree. And we have a very, very convoluted probability tree. Now, there's one other thing to talk about, and it's OR. If he takes path X or path Y, again with these probabilities, P little x, P little y, then to get the combined probability that he does path X or path Y, we add the 2 up. Okay? So why is this relevant? Well, let's focus in here just above B. So how does he get to B? Well, B he has to come down this way. How did he get here? Well, he came from here, or he came from here, or he came from here. So OR with probability means we add them. not and them, we add them. Okay. So now we have to ask ourselves, what is the probability he's heading down this tube over here, this tube on the left? Well, that's the probability that he goes down the 1/3, and then at the split in 2, he heads down this way. So he has to go 1/3 and then 1/2. So it's a probability of 1/3 times 1/2, or 1/6 that he's coming from this way. What's the probability that he just goes straight down the middle tube? Well, only one decision to make, and it's 1/3 of probability. How about that he's coming from the right? 1/3, and then he has to go down this path. And then he has to go down this path, so we multiply by probabilities again. So 1/3 times 1/3, 1/9. So what's the probability he reaches B? Well, it's the probability that he comes from this direction, or this direction, or this direction. So we add them all up. 1/6 plus 1/3 plus 1/9. And what can we do here? Well, we can take out a factor of 1/3. So we get 1/2 plus 1 plus 1/3. So we'll put those all over 6. So we'll get 3/6 plus 6/6 plus 2/6. So 1/3 times 11 over 6, and that's going to be 11 over 18, which I don't think was one of the answers, but it's got to be because the math is correct. Oh no, there it is, 11/18. C, 11/18. Okay. So hopefully, if you didn't know these connections for probability, that if you do this and this, you multiply probabilities together. If you have the choice of doing this or this, the probability that you do one of the two, you add the probabilities. This is a rough outline of how probability works. It's not always the case. There's more complicated things like conditional probability and all that fun stuff. But this knowledge of probability and the way we think about it this way suffices for our math contest needs. If you're interested in that sort of stuff, look up conditional probability. Look up repeated trials. That's great university stuff. Binomial theorem, equiprobable sample spaces. There's lots of fun stuff out there, but it might be a little more advanced than your average grade 10 course. So we're going to skip it and just know that and, multiply, or add, roughly. Okay? So that does it for question 18. In the next video, question 19. Thanks for watching, and I'll see you guys next time.